In the infinite blackness of space, a tiny spacecraft, no bigger than a car, drifts farther from Earth than any human-made object has ever ventured. Launched in 1977, this lone explorer, NASA's Voyager 1, has defied every expectation, outliving its creator's wildest dreams. For 46 years, it has journeyed through the cosmos, powered by technology older than a Walkman, sending whispers of data across billions of miles to a planet it will never see again. Its mission was meant to last just 4 years, a brief tour of the outer planets. Yet here it is, in 2025, still alive, still exploring, still rewriting the rules of what humanity believes is possible. But now, something extraordinary has happened. Voyager 1 has stumbled upon a discovery so shocking, so utterly impossible, that it has left scientists speechless and the world on the edge of its seat. What has this ancient probe found in the farthest reaches of space? Why is it shaking the foundations of everything we thought we knew about the universe? Buckle up, because this is a story that will leave you questioning reality itself. Picture this. It's the summer of 1977. Disco is king, bell-bottoms are everywhere, and NASA is about to pull off one of the boldest moves in human history. 2 spacecraft, twins in design, are launched just weeks apart, aimed at the stars. Their goal? To take advantage of a once-in-a-lifetime cosmic alignment, a rare moment when the gas giants, Jupiter, Saturn, Uranus, and Neptune, line up like pearls on a string. This celestial jackpot, which only happens every 176 years, allows a spacecraft to slingshot from one planet to the next, using their gravity like a cosmic catapult. Without this alignment, a trip to Neptune would take 30 years. With it, just 12. It's a gamble, a high-stakes bet on human ingenuity, and the stakes couldn't be higher. These probes, built with 1970s tech, think 8-track tapes and computers with less memory than a modern doorbell, are sent on a mission to explore the unknown. Little did anyone know they would become humanity's greatest explorers, carrying our hopes, dreams, and curiosity into the abyss. Fast forward to today, May 11th, 2025. Voyager 1 is 15 billion miles from Earth, so far that a single radio signal takes 22 hours to reach us. That's nearly a full day for a one-way message, traveling at the speed of light. Its power supply, a nuclear battery called a radioisotope, thermoelectric generator, is fading, producing just enough energy to keep its instruments humming. Its computers, with a measly 69 kilobytes of memory, are relics of a bygone era, yet they still manage to process data and beam it back to Earth using a transmitter no stronger than a refrigerator light bulb. The fact that this spacecraft is still operational is nothing short of a miracle. It's like a Model T Ford driving cross-country in 2025, passing Teslas on the highway. But Voyager 1 isn't just surviving, it's thriving. And it's just made a discovery that has turned the scientific world upside down. Let's rewind to understand the magnitude of this moment. When Voyager 1 launched, its mission was to study Jupiter and Saturn, snapping photos and collecting data on their moons, rings, and atmospheres. It delivered in spades, revealing active volcanoes on Jupiter's moon Io, a discovery that stunned scientists who thought moons were dead, rocky wastelands. It showed Saturn's rings in breathtaking detail, unveiling their intricate structure. By 1980, Voyager 1 had completed its primary mission, but instead of retiring, it kept going, propelled by its last gravitational assist from Saturn into the uncharted void. Its twin, Voyager 2, went on to visit Uranus and Neptune, becoming the only spacecraft to explore those distant worlds. Together, these probes rewrote textbooks, showing us that our solar system is far more dynamic and alive than we ever imagined. But the real adventure began when Voyager 1 crossed a boundary no one fully understood. The heliopause, the edge of our solar system. The heliopause is where the sun's influence ends, and the interstellar medium, the vast, mysterious space between stars, begins. Scientists expected this boundary to be a clear line, a cosmic border where everything changes. They predicted Voyager 1 would detect a surge in cosmic rays, high-energy particles from distant supernovae, and a shift in the magnetic field, from the sun's dominance to the chaotic pull of interstellar space. On August 25, 2012, Voyager 1 officially crossed this threshold, becoming the first human-made object to enter interstellar space. The data it sent back confirmed a spike in cosmic rays and a denser plasma environment, proof it had left the sun's protective bubble, the heliosphere. But there was a catch, something no one saw coming. The magnetic field didn't change as expected. It stayed aligned with the sun's field, defying every model scientists had built. This anomaly sparked a heated debate. Had Voyager 1 truly entered interstellar space, or was it stuck in some kind of cosmic limbo, a transition zone where the rules of physics blur? For years, scientists puzzled over this mystery, analyzing every byte of data Voyager 1 sent back. The probe's instruments, though limited, painted a picture of a region far stranger than anyone imagined. Interstellar space wasn't a uniform void. It was a chaotic, dynamic frontier, filled with pockets of plasma that varied wildly in density and temperature. Some regions were dense and hot, others sparse and cold, like clouds drifting through an invisible storm. These plasma clouds, as researchers began calling them, hinted at a turbulent history, possibly shaped by ancient supernova or stellar winds from long-dead stars. Each cloud was a clue, a snapshot of the galaxy's violent past. But in 2024, Voyager 1 detected something even more astonishing, a discovery so profound it's being called impossible. This is where the story takes a turn into the unknown, a revelation that could redefine our place in the cosmos. Imagine this. Voyager 1, drifting through the interstellar medium, suddenly picks up a signal, a faint rhythmic pulse, unlike anything it's encountered before. At first, scientists thought it was a glitch, a hiccup in the probe's aging systems. After all, Voyager 1's instruments are pushing 50 years old, operating in the harsh radiation of deep space. But as engineers analyzed the data, they ruled out equipment failure. The signal was real, and it was coming from outside the spacecraft. This wasn't random noise or cosmic static. It had a pattern, a structure that suggested something deliberate, something organized. The scientific community was floored. Could this be evidence of an alien presence, a message from another civilization? Or was it a natural phenomenon, some undiscovered process in the interstellar medium? The possibilities were dizzying, and the implications were staggering. Let's break this down. The signal detected by Voyager 1 is a series of low-frequency electromagnetic waves oscillating in a way that mimics a heartbeat. It's not a radio broadcast like we'd expect from a sci-fi movie, but it's consistent, repeating at regular intervals. The probe's plasma wave instrument, designed to measure vibrations in the interstellar medium, picked it up while scanning the surrounding plasma clouds. The signal's frequency is unlike anything produced by known astrophysical phenomena, such as pulsars or black holes. Pulsars, for example, emit rapid, predictable pulses, but this signal is slower, almost deliberate, and it doesn't match their signatures. Black holes might produce gravitational waves, but those are far beyond Voyager's ability to detect. This signal is something else entirely, and it's coming from a region of space that's otherwise silent. Scientists are racing to understand what this means. One theory is that the signal could be a natural artifact of the interstellar medium, perhaps caused by interactions between plasma clouds and magnetic fields. The interstellar medium is a complex soup of charged particles, dust, and gas shaped by the remnants of ancient stellar explosions. It's possible that these plasma clouds, compressed by magnetic forces, are generating low-frequency waves that Voyager just happened to stumble across. But the signal's regularity raises doubts. Natural processes tend to be chaotic, not rhythmic. Another more daring hypothesis is that the signal could be artificial, a beacon or marker left by an advanced civilization. This idea, while thrilling, is met with skepticism. Voyager 1 is 15 billion miles from Earth, but in cosmic terms, that's still our backyard. The odds of encountering an alien signal so close to home are astronomically low. Yet, the possibility can't be ruled out, and it's fueling intense debate. To put this in perspective, Voyager 1 carries a golden record, a time capsule meant for any intelligent life that might find it. The record contains sounds and images of Earth, music, greetings in 55 languages, even the sound of a mother's kiss. It's humanity's handshake to the stars, a message that says, "We're here." Could Voyager have stumbled upon someone else's version of a golden record? The thought is electrifying, but scientists are cautious. Extraordinary claims require extraordinary evidence, and right now, the data is limited. Voyager's instruments weren't designed to hunt for alien signals. They were built to study planets and plasma. The probe's dwindling power supply, now at less than 30% of its original capacity, limits how much data it can collect and send. Every byte is precious, and engineers are working around the clock to keep the mission alive. As news of the discovery spreads, the world is gripped by a mix of awe and uncertainty. Social media is ablaze with speculation, from hopeful dreams of first contact to fears of what an alien signal might mean. Posts on platforms like X are calling it the biggest moment in human history and proof we're not alone. Others are more skeptical, pointing out that Voyager's data is noisy and open to interpretation. Meanwhile, scientists are urging calm, emphasizing that the signal could have a natural explanation. They're reanalyzing decades of Voyager data, looking for clues that might have been missed. They're also turning to other observatories like the James Webb Space Telescope to scan the region of space where Voyager detected the signal. If the signal is artificial, it could point to a source, a star system, a rogue planet, or something entirely unknown. If it's natural, it could reveal new physics, a process we've never observed before. Let's step back and consider what Voyager 1 has already taught us. This tiny probe, launched when many of today's scientists were babies, has survived radiation belts, asteroid fields, and the crushing loneliness of deep space. It's outlasted its designer's predictions, operating decades beyond its planned lifespan. Its journey through the heliosphere showed us the sun's reach, a bubble of plasma that shields our solar system from the galaxy's harsh radiation. Its crossing into interstellar space proved that humanity could touch the stars, even if only with a robotic emissary. Now, with this new discovery, Voyager 1 is challenging us to rethink our place in the universe. Are we alone, or are we part of something bigger? Is the cosmos a silent void, or is it humming with life, waiting for us to listen? The emotional weight of this moment is hard to overstate. Voyager 1 is a relic of a more optimistic era, a time when humanity looked to the stars with wonder, not fear. It carries our dreams etched in gold, a message of peace and curiosity. For 46 years, it's been our eyes and ears in the unknown, a testament to what we can achieve when we dare to explore. Now, as it drifts through the interstellar void, it's sending us a message that could change everything. Whether the signal is a natural quirk or a cosmic hello, it's a reminder that the universe is vast, strange, and full of surprises. Voyager 1, battered but unbowed, is still out there, fighting to tell us more. Its nuclear battery will fade by 2030, silencing its voice forever, but until then, it's our guide into the unknown. Imagine the scientists who built Voyager working with slide rules and punch cards, dreaming of the day their creation would reach the stars. They couldn't have known it would outlive them, or that it would stumble upon a mystery that captivates the world. Imagine the engineers today coaxing every last watt from a dying spacecraft, knowing each signal could be the last. Imagine the billions of people on Earth looking up at the night sky, wondering if we're about to meet our neighbors. This is a story of courage, curiosity, and the relentless human spirit. It's a story that reminds us why we explore, not just to find answers, but to ask better questions. As Voyager 1 continues its journey, scientists are scrambling to make sense of the signal. They're running simulations, testing theories, and debating what comes next. Some argue for redirecting the probe's antenna to focus on the signal's source, though that risks losing contact with Earth. Others want to conserve power, prioritizing the data we already have. The clock is ticking. Voyager's power supply is expected to run out in the next few years, and when it does, the probe will drift silently, a monument to human ambition. Until then, every transmission is a gift, a chance to learn something new about the universe and ourselves. The discovery has sparked a global conversation about what it means to be human in a universe that might not be empty. If the signal is artificial, it could be the first step toward answering the age-old question: are we alone? If it's natural, it's a humbling reminder that the cosmos is stranger than we can imagine. Either way, Voyager 1 has given us a reason to look up, to dream, and to wonder. It's a call to keep exploring, to keep pushing the boundaries of what's possible. The probe's journey is far from over, and neither is ours. In the coming months, scientists will pore over the data, searching for patterns that could unlock the signal's secrets. They'll collaborate across disciplines from astrophysics to exobiology to prepare for every possibility. The world will watch, holding its breath, as we take our next steps into the unknown. Voyager 1, a 46-year-old relic, has become the spark that ignites our imagination. It's proof that even in the darkest corners of space, there's light. Light that carries our hopes, our fears, and our unyielding desire to know more. So what do you think? Is Voyager 1's discovery a glimpse of alien life, or a new chapter in our understanding of the cosmos? Share your thoughts in the comments below. If this story moved you, hit the like button and subscribe for more updates on this incredible journey. Voyager 1 is out there, 15 billion miles away, carrying humanity's dreams into the stars. Let's keep listening, because the universe might just be talking back. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.